Okay, so we are taking, and this might take us today and part of tomorrow to get through this, okay, because it is a little bit bigger of a lesson. We'll see. We might be able to get it done in one day. We're taking our first step into trigonometry that's beyond the right triangle, okay? There's a lot more to trig than what you learned last year, okay? We could have done an entire semester on it if we really wanted to, okay? We're going to try. Our goal is between now and the end of the school year to get through as much as we possibly can, to get you prepared to be able to for what you need next year. Okay. All right. So we've got. Oh, I didn't put my little color coding on there, so I'll have to come back and do that. I'll see if I can get it on there for tomorrow. So I don't think in that first sentence there's anything you probably can't pronounce. It's called radians. Okay. So on the count of 3, we're going to read this out loud together. I know you guys can do this. Okay. I know you can be louder than my first period. Okay. I want you to try to be louder than my second period, which they can hear in Mrs. Artifer's room across the hall there. So, all right. On the count of 3, you ready? Just the first sentence. 1, 2, 3. That's the best you guys have done in a while. Nice job. Okay. So we're going to do a conversion process once we go through a lot of vocabulary. Okay. All right. This next one here, that word is called coterminal. Okay. Coterminal. All right. So on the count of 3, we're going to read that one out loud. You ready? 1, 2, 3. Perfect. Okay. I know that there's not a lot of vocabulary you probably know in there. You probably know that we measure angles in degrees. We're also going to have another measurement called radians. Okay. And we're in this transition process. We're going to flip back and forth between the two. We go to calculus, we only use radians. Okay. So we're kind of making that transition from geometry to calculus right now. Okay. And angles, obviously, you know what that is, right? It's got a vertex. It's got a couple of sides. We've been working with them in triangles. Okay. So let's talk about the vocabulary. I'm going to flip to another one that has the vocabulary typed out. Okay. So, trigonometry. Okay. It's the Greek word for the measurement of triangles. So it has to do with triangles, but it isn't just triangles. Okay. We have some measurements in there and stuff that we're bridging from right triangles to the rest of trigonometry. Okay. All right, so an angle. And again, I said I had you guys do this yesterday, so we don't have to wait and I can just go through the vocab really quick. Okay. So an angle is determined by rotating a half line or a ray about its endpoint. So here's a ray right here. Okay. And if we rotate it about its endpoint, which ends up being the vertex, that gives us an angle. Okay. The terminal side of an angle is the position of the ray after the rotation. So after I rotate it, we have it. Terminal means end, right? It stands for the word end. So my ending side is the terminal side. It's where if I rotate that initial side, it's where it lands, and that's what creates the angle. Okay. The vertex is the end point of the ray used in the formation of the angle. So the two rays, that makes the vertex of the angle. That should be something you remember from last year, probably even from like 5th grade. Okay. We say an angle's in standard position when its vertex is at the origin on the coordinate plane. We're going to mostly work with this. We're not going to work with what's up above there. We're going to work with the one below here. We're going to put the angle on the coordinate plane. Okay. That's how we're going to do our trigonometry. Okay. All right. I want to peek here and make sure I'm not missing something on this. That I don't have to fill in anything in between. Okay. So positive angle, negative angle, coterm. Okay. Oops. That was the wrong button. All right. So a positive angle is generated by a counterclockwise rotation. Okay. I know we use mostly digital clocks now. Okay. But back when clocks had like the hands, right? Counterclockwise means you go up first. Okay. Clockwise is you get a negative angle. So clockwise means you go down first. Okay. It's a down rotation versus going up. We always start our rotating in quadrant 1. Okay. And it gives you a little bit of a graphic there. So positive is going to go up, negative is going to go down, which makes sense in our brains, right? It's positive seems like something up, negative seems like something down. Okay. All right. I'm going to keep flipping and making sure I'm not missing anything. Okay. Coterminals next. All right. So two angles are coterminal, then they have the same initial side and the same terminal side. Okay, so here's the deal. Up until this point, you've really only worked with angles that are between 0 and 180 degrees. But guess what? We can have angles that are bigger than that. Okay? We can go all the way around the circle. Does anybody know how many degrees if we go all the way around the circle? There's 360 degrees all the way around the circle. Have you ever watched like a skateboarding or a snowboarding competition? Don't they say they flip like a 1080 or a like 520, right? That means they're rotating. They're actually doing trigonometry right there. They're rotating more than one time around, right? That's how they talk about it, is how many degrees they're rotating, okay? Well, that's what this concept is right here, okay? So I could have a coterminal angle means if I go in the positive direction, it ends right here. But I have another angle that I can name with a negative number in the negative direction, and it has the same ending ray. Okay. In this one here, I could go the short angle and just go up a little bit, or I could go all the way around one time and then end at that angle. Okay. And that, as long as when they're end at the same place, they're called coterminal. Okay. There's a couple of Greek letters on the screen. I want to talk about those really quick because mathematicians ran out of English letters, so they start using Greek ones. We see this one a lot for angles, theta. Okay. And that's this. That's how you say it, theta. Anybody know what this one is that looks like the fish? That's alpha. Okay. And what's the B one? Do we know that one? That one's beta. Yeah. Okay. So it's alpha and beta. All right. And really, we tend to stick with those three for this class. Every once in a while, they might throw something else weird at us, but those three are the ones you should kind of know. Okay. All right. That flips us to the second page, right? So the second page, at the top of the second page of your notes on page 129. Okay. We have the measure of an angle is the amount of rotation required to rotate one side called the initial side to the other side called the terminal side. Okay. All right. And then they talk about the definition of a radian. Okay. So 1 radian, which you can abbreviate RAD. You might see that when we get out our graphing calculators eventually. You see RAD, okay, in there. Is the measure of the central angle that intercepts the arc equal to the length of the radius of the circle, okay? So what that means, remember a central angle is something that comes out of the center of the circle, okay? And they're saying that the measure of this angle, it intercepts the arc of the circle, okay? To get theta, we don't do this calculation. It's just showing you the background, okay? That that arc length, we divide it by the radius, and then that gives us a radian measure. Okay, that's where the radians come from. Okay. All right. A central angle is an angle whose vertex is in the center of the circle. We already talked about that. Okay. Looking at this next part here. Okay. So the second box, and then we actually get to do something. Okay. So a central angle of 1 full revolution clockwise corresponds to the arc length of 2 pi r. Okay. So if we go all the way around, so radians are measured in pies. Okay. And it has to do with our circumference of our circle. So we know that we do the circumference of a circle, it's 2 pi times the radius. Okay. So that takes us 1 revolution around the circle. Notice we can get barely 6 radians into a whole revolution, and we've got a little bit left. Okay. Half of a revolution, okay, is what we consider pi radians. Okay. Pi radians. Okay. 1/4 of a revolution around the circle is what we would consider pi over 2 radians. Because this is 2 pi radians, right? Half of it would be pi. Half of pi would be pi over 2. Okay. 1/6 of a revolution is what we would consider pi over 3 radians. Okay. And then they give us, oh, I got to scroll to the next. Let me pick back up on this picture here. Okay. So you guys are like right here. So you'll notice that these are some common angles. You're going to get to know and love these. All right. This is what we use all the time. All right. In this class. I'm not sure what I was supposed to put here because I don't have my extra notes in front of me. So let's look at acute and obtuse. Okay. So acute, hopefully you know what acute and obtuse are. Those are not new concepts. So an acute angle is between 0 and 90, or 0 and pi over 2. And obtuse is between 90 and 180, or pi over 2 and pi. Okay. All right, we're going to learn how to count again. You ready to learn how to count? So we're going to do some radian counting. Okay. There are 3 worlds we live in trigonometry. Okay, when we're talking about radian measure. All right. So all we're going to do is learn how to count. Okay. We live in over 6 world, over 4 world, and over 3 world. Okay. So I'm going to use these little guys to count, and this is going to help us eventually. This transitions us into what we call the unit circle. Okay. And if you ask most people about trigonometry, they're going to talk to you about the unit circle. That's what they probably remember. Okay. So I am going to start with over 6 world. Okay. So this is going to be my pi over 6 circle. All right. Whatever my denominator is, that's how many I divide my top half into. Okay. So I'm going to start here in the center. Okay. And then I know I'm going to have, I want 6 pi wedges total in the top. And I also want 6 pi wedges total in the bottom. So the denominator tells me how many wedges in half the circle. Okay, now I'm just going to count the wedges. All right, so I start on the axis with 0, and then I'm going to count up. I'm going to go up because that's my positive angles. So this is 1 pi over 6. The next one would be 2 pi over 6. What do you think the next one's going to be? 3 pi over 6. I can always count it. Okay. The next one would be 4 pi over 6. The next one would be 5 pi over 6. See, this is pretty easy, right? All I gotta do is count. All we're doing is adding 1 to each numerator, right? The next one would be 6 pi over 6. All right, then I'm going to go to the next one. 7 pi over 6. 8 pi over 6. 9 pi over 6. 10 pi over 6. 11 pi over 6. If I haven't quite closed the revolution, so this represents 0. It also represents 12 pi over 6. But think about it, a lot of those fractions can be reduced, right? I'm not going to reduce them in that picture, but they could be reduced. How many times does 6 go into 12? 2. So so it's really representing 2 pi, even though I wrote it as 12 pi over 6. Okay. All right. So that was the over 6 world. Okay. Actually, I should have labeled that. Let me label that underneath. Okay. So this is the pi over 6 circle. Okay. I am going to do the pi over 3 circle next. Okay. So if my denominator is 3, how many wedges am I dividing the top half into? 3. So I've got to divide it into 3 wedges. All right, we're going to count. right? Start with 0. My first wedge ends at 1 pi over 3. Where does my next wedge? What's my next wedge then? 2 pi over 3. What's my next wedge? 3 pi over 3. Good. What's my next wedge? 4. Good. 4 pi over 3. And then what's my next wedge? Good. And it's always good to go the whole revolution so you can check to make sure you did it right. Okay? What's the last one going to be? Be 6 pi over 3. What? How many times does 3 go into 6? 2. So I still have 2 pi there. Okay? And you'll notice, look at halfway around. What happens with the 6 over 6 and the 3 over 3? They cancel. So halfway around is just pi. Okay, and so that's another good checkpoint to make sure you've counted your wedges correctly. Once you get halfway, you should be at pi. Okay. All right. The last one we're going to do is over 4 world. And I actually purposely chose the colors red, green, or blue, green, and red because these come up in those colors later on. Okay. All right. If I am over 4, how many pi wedges am I dividing the numerator, the top half into? 4. Okay, so I'm going to go here. I'm going to go here, and I'm going to go here. Might as well draw the line all the way across. And I've got 4 wedges on the top and 4 wedges on the bottom. Okay. I start counting with what number? Where does my circle start at? 0. Good. Okay, and then I'm going to go 1 pi over 4. And then the top I'm going to do 2 pi over 4. Okay, I want you to see if you can label the rest of it. So everybody try the rest of the labels right now. Just count it. Remember, by the halfway point, it should reduce to pi. All the way around, it should reduce to 2 pi. All right, I'm going to write mine on there really quick. You can check it against mine. So 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. Did I end with 2 pi? Yep. And halfway through, I had 4 over 4, so that cancels to pi. Okay? All right. That was kind of a break from our regularly scheduled programming because I just wanted to make sure we understood how to count the wedges. Okay? That should help us in the rest of the lesson. Okay? So remember, 1 full revolution around is 2 pi. That comes up. We need that information for these first few examples here. Okay? So read the instructions to yourself. 10 seconds, read them to yourself. I now remember what I was supposed to do earlier. Okay, so we have to determine the quadrant that each angle lies in, and the angle measure is given in radians right now. So we're doing this not in degrees, we're doing it in radians. I remember now what was supposed to go here. So that's a good thing, right? I was supposed to number the quadrants, okay? You need to, just like on today's, what we did for our, our little silly question this morning, the quadrants were labeled, right? So the quadrants all have names. This is quadrant 1. They're named with Roman numerals. Okay, this is quadrant 2. This is quadrant 3. And this is quadrant 4. Okay, it makes like the letter C. Okay, when you go around. So when you you go in the direction of the letter C. All right. And it is supposed to be. We were on vacation up in February. We were up in Utah. We were visiting we actually visiting Mrs. Bailey's daughter. at college, and we saw a clock that did the Roman numeral 4 like that. I was like really appalled because one of my kids asked me about it. They're like, Mom, is that right? It's not. It should be 1 before 5. That's what it means. Okay, so we got to determine the quadrant. All right, so I'm going to count my wedges. All right, so I'm going to use that same what we just did with the wedge counting on this problem. Okay, so I'm going to start by drawing myself a nice little XY axis. Okay, so you got to draw your own. I didn't give it to you this time. Okay, all right. The next thing I'm going to do is my denominator tells me how many how many wedges I'm supposed to divide into. So what's my top part have to divide? How many wedges do I need to divide into? 4. Okay, so I'm going to try to sketch that in there. 1, 2, 3, 4. And I'm going to go this way. I'm going to go 1, 2, 3, 4. So I've got my 4 wedges in there now. Okay. I am going to count this many now. So how many wedges do I need to count? 5. Okay, so I'm always starting here at 0. I'm not going to label it. I'm just going to make little marks. So here's 1, 2, 3, 4, 5. That's the 5 pi over 4. What quadrant did I land in there? I'm in quadrant 3. That's the answer. You're going to find that we do a lot of thinking and not a lot of written work. Okay, and that the answers are pretty simple. It's just a Roman numeral 3. Okay. Yeah. Yep. Because all I'm trying to do is determine what quadrant number I'm in, and this is in quadrant number 3. Okay. All right. Let's start this one together. I'm going to have you probably finish it. So here's I'm not going to draw the top part of my axis. I'm going to go here. Okay. I'm going to dash that in there, okay? So, how many wedges do I need to divide the top into? 3. Okay, so I want you to try to divide it into 3 wedges, and I want you to try to count 5 of them, okay? I only dashed that in there so you knew where the quadrants were. That's not part of your wedges, okay? So try it on your own really quick. Give you like 30 seconds, a head start on me. Yeah. So, because that's what the question is asking us is what quadrant you're in. Okay. Okay, I'm going to divide into 3. So I know I've got 1, 2, and then that becomes 3. So I'm going to do something like this, right? How many do I want to count? 5. Okay, so I'm counting 5. 1, 2, 3, 4, 5. What? Oh, sorry. I'm all the way here. 5. So what quadrant did I land in? You landed in 4th. Okay. All right. The next one's weird because we didn't have an over 12 world, but we've got to come up with an over 12 world on this one. Okay. So let's see what we can do with it. I'm going to draw my picture. I know, and it's negative too. That's even another challenge. So we'll talk about the negative part in just a second. Okay. How many do I need to divide the top and the bottom into? So how many do I need to divide the top piece into? How many wedges? 12. 12 on the top and 12 on the bottom for a total of 24 wedges, right? All right, let's see if we can do it. So I'm going to go halfway here just to see what I can do with that. And let's see, that means I need to get 6 in here, right? 1, 2, 3, 4. Okay, so I think I got 6. 1, 2, 3, 4, 5, 6. All right, I'm going to do that here too. In every quadrant, isn't that nice? Okay, I'm going to do it again down here. Okay. That was terrible looking, but hopefully we get the idea. It's definitely, I did not divide mine very evenly, did I? All right, so I now need to count how many. 7. But the negative is going to tell me whether the negative and positive tells me whether I go up or whether I go down. So we've been going up. What do you think the negative is going to mean I do? I'm going to count it down first. Okay, so let's see what quadrant we land in. So here's 1, 2, 3, 4, 5, 6, 7. What quadrant did I land in? Quadrant 3. Oh boy, I almost did a Roman numeral 4 wrong, didn't I? All right. Any questions on how to determine your quadrant? Okay. All right. This is almost the same thing. It wants me to sketch the angle in standard position. All I would have had to do on this one is just add this thing here, and then it's pretty much the angle, okay? So we've really done it. It's just in asking the question in a different way, okay? So I'm going to start by drawing myself a nice XY axis, okay? And I'm going to kind of lightly draw my my guidelines there, okay? So technically, how many wedges do I need to divide the top part into? 6. So instead of drawing solid lines, I'm going to draw dashed lines, okay? So 1, 2, it would be 3, 4, 5, 6. I'm going to divide this up, okay? Because I want my solid line to represent the actual angle. Okay, that's why I switched to dashed lines. Okay, an angle in standard position is going to start on the positive x-axis. All right. How many wedges do I need to count to get the angle? 7. Am I going to go up first or down first? Up. So I'm going to count 1, 2, 3, 4, 5, 6, 7. That's where I end. And I'm actually going to leave that arc on there. And I'm going to put a little arrow with the direction that I went. So that right there would represent 7 pi over 6. Okay. And as long as you showed me that, I know it's not precise, but you'd at least land in the right quadrant. That's what I'm looking for here. Okay. All right. I'm going to try it a little bit together again. Okay. So looking at B. Technically, how much do I want to divide the top and the bottom into? 3. Okay, so I got to divide into 3. And then how many am I going to count? How many wedges am I going to count? 2. Okay, so I want you to try it from there. Okay? Try to divide the top into 3. And then count 2 wedges.
No.
Okay, let's check it. So I'm going to divide my top into 3. I'm dashing that in there, right? Okay. Do I want to count up or down? Up. So I'm going to draw my solid there, and I'm going to go 1, 2. And I'm going to put my little arrow pointing that way, and I'm probably going to label 2 pi over 3. Okay. What's wrong? On the beginning, so my blue lines, right? I divided all. I drew them all instead of drawing just the ones in the top. So you really only needed the ones in the top. So I divided my top into 3, right? And I also divided my bottom into 3. Okay. Going across because that's my third wedge, right? So it's 1, 2, 3 to hit that, and then another 1, 2, 3 to hit that. You don't have to draw them. No, because it's on an axis. Yeah. Okay. Okay. I drew it over the top of the axis. You don't have to do that. Okay. All right. I want everybody to try C on your own from beginning to end. Okay. You can do this. Okay. Make sure you notice it's negative. So you make sure you go the right direction. Yeah. And we're done. There's a line when we're done now.
There's a line.
Yeah.
What? The search and rescue part.
Yeah.
It is like a video I would have put outside.
I'm sorry. Sure, it was just my head was not in the right place. Probably. Okay, we're gonna check it. You ready? All right. How many wedges were you supposed to divide into? 3. Okay, so I'm gonna go 3 on the top. I'm gonna do it in Elise's way. I'm not gonna draw that extra one across the axis. Okay. All right. So I'm gonna go. And do I want to go up or down? Down. So how many do I need to count? 4. Okay. So 1, 2, 2, 3, 4 is gonna land there, right? 1, 2. Oh, I counted too many. Hang on. I messed it up. I'm going to do it again because I think I was off. All right. So here's 1 wedge, 2 wedge, 3 wedge, 4 wedge. It should end here. Okay.
Why on the first example, the lines 6 in each quadrant? Not 4. See, second example.
Say that one more time.
Okay. On the third one, for
Uh-huh.
this example, you made us do the line 6 times in each quadrant.
Okay. On this one up here?
Yeah.
Okay. Yep. Okay. So what was my denominator? 12. So I needed to have 12 wedges on the top. And then this one here, what's my denominator? So I needed to have 6 wedges on the top. Yeah. Okay. Got it? Okay. I'm going to stop there because I think that's enough for today. Okay. We're going to finish this tomorrow. All right. I'm not giving homework yet. All right. Tomorrow, remember, we're doing our angle of elevation, angle of depression quiz. Okay. So that's a 1 question tomorrow. All right. All right, Giselle, do I have your ID? A 1 question quiz on angle of elevation and depression. You can do that. Yeah.
This what we're doing right now, it's the quiz tomorrow? Or
No, it's on the angle of elevation and depression we did at the beginning. It's just a skills check quiz.
The quiz is next week for this?
For this, probably sometime next week, yeah.
Miss Valerie, is it gonna be like the Otis or something for the weekly question?
Yeah, it'll be Otis. Yeah. Yeah.
Otis?
Yeah. Do we ever not use Otis?